your host, Tom Goldsby, coming to you from the University of Tennessee at Knoxville, Tennessee, and it's my pleasure to welcome you to today's masterclass session titled Energy Efficiency in Cold Chain. We are pleased to welcome a returning guest to the masterclass series. Mr. Mark Vogt, Head of International Sales, is with us today out of Germany. We're delighted to have Mark with us. And I'll provide a more formal introduction, Mark, in just a moment, but I want to encourage everyone out there to be involved in today's session. Please take a look at today's handout, which is an infographic that comes to us from Körber Supply Chain about how you can be more sustainable throughout your supply chain. And in particular, we're going to look at how you can be more energy efficient in the cold chain today. And in that regard, we welcome your questions at any time. If you have a question during the webinar, just please submit that question. I'll be monitoring them and directing them to Mark toward the end of the session. But without further ado, again, my name is Tom Goldsby, and I will serve as the host of today's session. I'm the James A. Haslam Chair of Logistics at the University of Tennessee in Knoxville, Tennessee. I'm the past editor of the Journal of Business and Logistics and also the Transportation Journal, and I serve on some boards of directors for some professional societies, namely the Council of Supply Chain Management Professionals and the Supply Chain Logistics Institute at the University of Tennessee. Our featured speaker is Mr. Mark Vogt, and he is the head of international sales and automation at Körber Supply Chain. As I indicated, he's a veteran speaker in the Körber Masterclass series, having served as a subject matter expert in previous masterclasses. And Mark, it's great to have you back with us. I'm going to turn things over to you in just a few minutes, but please allow me to go over a few items first. For one, some of you may be joining us for the first time and may be wondering why we're here, what we're trying to accomplish. Well, the purpose of this masterclass series is to tackle the challenges of today's increasingly complex supply chain, bringing you best practices and innovative thinking from academics like myself, as well as industry insiders and senior leaders like Mark. Maybe no topic is as perplexing today as delivering on the multiple bottom lines that sustainability presents, delivering on business objectives, conserving on our physical environment, and also looking out for the well-being of our associates, supply chain partners, and larger society and communities in which we operate. Our intention is to educate and inform, illuminating how the pursuit of sustainability done well can advance your business. You see that today's session is one of several that we're offering, four to be precise on this subject. Today is the second of the 4 sessions, and we're going to offer those successive sessions at the same time over the next 2 weeks. The session on dark warehouses next Tuesday and paper-free warehouses in a couple of weeks on Thursday, February 25. Note that we have a catalog of recently completed master classes that are also available to you on demand. You can review any of these 6 masterclass series consisting of 4 or 5 30-minute action-packed sessions dedicated to contemporary topics in supply chain management and advanced technologies. So with that understanding, let's quickly go over some housekeeping items. Your phone lines are muted out there, but we do want to hear from you in the form of your questions, and you can submit your questions at any point during our broadcast today. Note that a recording of today's class will be available within 48 hours of its conclusion, as well as the slides that Mark and I will be going over here in just a moment. And again, don't forget to go to that GoToWebinar menu to check out the handout that's available. Today's infographic is focused on how you can achieve better sustainability throughout your supply chain. A lot of really great items of information found in that infographic. And also, again, don't forget about those questions. Now, with regard to questions, let's go back and revisit the poll question that you saw at the outset that asked, what steps are you taking to improve energy efficiency in cold chain? And 67% of you indicated process improvement, which is fantastic to see that you're recognizing that it's possible to maybe be lean as well as green and sustainable. And that's certainly vital, I think, in how we become less energy intensive in our cold chain. So that's pretty fascinating to see. 2/3 of you indicated process improvements. 22% of you indicated something else other than the 4 options we had. Next in order was energy management. 11% of you indicated that. And we got 0% indicating automation and robotics, which I think Mark is going to illustrate a lot of opportunity there for improvements. Hey, Mark, can I bring you into the conversation here? Any reactions to what you see in our poll question today, with 2/3 of the people indicating that process improvement is the way that they're achieving energy efficiency in their cold chains?
Was it a question to me, Tom?
Yes, Mark, I was just curious if you had a reaction to the poll results.
It's absolutely impressive, this number. So 67% of the participants are thinking about process improvements. I think that's quite an impressive number, yes.
And you're going to be talking more about that here in just a few minutes, as well as some of the more advanced opportunities to introduce technology like automation and robotics. So we'll get to that again in just a moment. But thanks for completing our poll question out there. That provides some interesting level set for us as we get into the topic today. So I'm just going to provide a couple of minutes of level set here before turning things over to Mark. But I went to some macroeconomic data that came from the U.S. Department of Energy for these 2 pie charts that look at how much of the commercial building space in the United States is dedicated to warehousing and storage. And you see that in terms of building count, the number of buildings throughout commercial enterprise of all kinds in the United States, that warehousing and storage represents the single largest category. And this is a little bit of a shift because we've actually seen growth in warehousing and storage, as I'll share in a moment, but actually a decline in office space. And that has certainly continued in recent months as we're seeing more demand for distribution and maybe a little less demand for office space. So we expect that trend to continue. Also, if you look at how floor space is allocated around the country, again, warehouse and storage is the largest user of commercial building floor space at 18%, again, slightly outpacing office and other purposes. Now, if we can look at the next slide, it'll show that growth trajectory from the period 2012 to 2018. You notice that warehousing and storage, again, is the single most common purpose for commercial buildings. But what you'll notice in that long blue line is that it indicates that it's seen significant growth, 26% growth from 2012 to 2018 in terms of space usage. And these data are quite fresh from the U.S. Energy Information Administration of DOE, Department of Energy. But I think if we looked at the last 2 years, we would see even more growth in warehouse and storage than what is depicted here in that previous 6-year time frame. Now let's take the conversation where we want to take it for today's purposes to energy consumption. And the next slide speaks of the total amount of warehouse space that is dedicated to refrigeration, cold chain. And you see that it's only about 10% of all warehouse space in the United States is dedicated to refrigerated temperature control purposes. However, when you look at the pie chart on the right, you see that more than its fair share of energy consumption comes from refrigeration. It consumes, in fact, 16% of all the energy consumed in warehousing goes toward refrigeration. And that point at the bottom underscores refrigerated space is 5 times more energy intensive per square foot, and you see the metrics in kilowatt hours there, than non-refrigeration. And so I think that this helps to set you up, Mark, maybe for some in-depth commentary and help us to better understand how we can consume less energy despite the fact that the demands on our cold chain are unprecedented. and growing. So Mark, again, I'm going to bring you into the conversation to share some best practices in achieving better energy efficiency in cold chain. Where are the opportunities?
Well, first of all, Tom, thank you very much for the introduction. And I have to say, it's once again a pleasure for me to make another masterclass series with you. And to all the others, a warm welcome from my side as well. I'm happy to have you online and that you are interested in this topic, because I think this is really an interesting topic, especially for the future. And if you see this slide here, especially on the left side, this topic is driven also by us, by the consumers. All the customers, consumers, they are changing the consumption habits to reduce the impact on the environment and to take care about the nature and the resources. And this is also the trigger for the companies, that they also have to change their behaviors and that they have to change their habits concerning sustainability and taking care about the resources. And that comes to the end that the supply chain, which are all companies are driven by, that the supply chain has to be changed, and that we have to take care more about efficiency and save the environment and take care about the environment. And one famous topic, or maybe the biggest topic out of it, is the energy. And that's the topic, that's the matter of today. How can we get to the energy efficiency, and especially for buildings and warehouses, not only for the deep frozen environment, also for the normal temperature. I think it's a matter for all warehouses and all the buildings. Coming to the next slide. I just would like to give you two examples how big the potential is for saving the energy. If you take the market in UK, for example, and invest in all the different warehouses in energy efficient equipment, you can save around $260 million just saving by energy reduction. And if you see the US market, maybe you already recognize this slide from Tom. Tom provided already this slide. We have 79 billion we have 79 billion floor space in square foot all over the warehouses in US. And if you calculate them by 2.10 US dollars per square foot, you get the costs for it. And if you take an advantage for reducing the energy costs, you can save around $3 to up to $5 billion in the energy. So this is really quite a big amount for potentials in saving the energy. Overall, there is a statement that for the efficiency, you can save up to 22% by using, in the normal operation of a warehouse. The next question is how we can save such a kind of big amount of savings in the energy. If you consider where the energy is used in a warehouse, you see the upper display here. You have the lighting, you have material equipment, more or less, you have cooling, refrigeration, computing, ventilation, and other technical equipment. And if you have just an average, if over the different warehouses, you can see the most potential is in the lighting, the 34% of the volume. We as Körber, we did our own case study. We, together with a customer in the south of Germany, in Stuttgart, a customer who is delivering books to shops and also doing an e-commerce business. We analyzed together with the customer his energy consumption, and of course there are the same factors, but this warehouse was already organized by software, and we find out that is around 65% of the volume is spent or wasted by the lightning. So that should show you that it is not a general question. Where is it worth to go for it? First of all, you have to make an analysis. You have to get you have to deep dive in your warehouse, in your processes, because each warehouse has different sizes, has different processes. Maybe some of them are with technology, some of them are with less technology driven, manual. So each warehouse is different, and first of all, you have to make an analysis where most of the energy is spent or wasted, and then you can make some results, and you can make some strategy how to reduce it. The next question is, what exactly can we then do if we have found out where we spend most of the energy? And that's the answer is in the next slide. We see there are more or less three main areas, three main topics where you have to take care about it, and where we can search for savings. On the left side, you see sustainable warehouse design. So first of all, the design of a new warehouse, the design of the technical equipment of the warehouse influence, of course, the waste of energy, and define how sustainable a warehouse is. If you see the above topic, it's the energy efficiency through the warehouse. So how is the operation in the warehouse? Is the technical equipment used? What kind of technical equipment is it? Is it a modern one, or is it maybe an old one, maybe not the best one for the operation? So that influence, of course, also the consumption of energy. And on the right side, and I think that is what a lot of participants at the beginning and choose from the questions, what kind of process automation, what kind of processes you can maybe do it better, or you can control, or you can make it transparent to reduce then the energy. And in the next slide, I would like to give you an example where all these three topics are merged together. It's an example from a warehouse built in 2019, so 2 years ago, in the Netherlands. And this warehouse, which you can see here in the picture, is one of the world's greenest industrial building. So with this futuristic curved design and daylight infused interior, it does not look like a typical warehouse. I think it's more a future building than a warehouse. But overall, it has around 60,000 square meters warehouse and offices, and it's airtight with extra insulation. A photovoltaic system on the roof consisting of more than 11,000 solar panels generates the electricity, and generates more electricity than the building is consuming. And the surplus energy is fed back into the grid, into the network. And that means at the end that this warehouse is energy and CO2 neutral. So that is really a great topic. On the other hand, there are some additional topics. For example, the toilets are flushed with rainwater, which was collected from the roof. The natural light fluting through large windows reduces the amount of electricity needed, but also makes the workspace or the space for working in a pleasant atmosphere for the workers. The building with the nickname The Tube got the highest rating ever for the distribution center with a score of 99.48%. So more or less almost 100% what you currently can do to save energy, to reduce the influences on the environment and so on. So this project aims to eliminate waste and reduce and reuse and recycle where possible and save the environment. Next slide, please. Can we go to the next slide, please? What does it mean for a warehouse inside? So what we just have seen was an example for the building, for the design of the building, and for the technical equipment to run the warehouse. But of course, there is also some technical equipment inside of a warehouse to run the operations. You can do it more or less manual, but you can also use automated guided vehicles. You can use robots, or you can, if you have picking process, you can have pick by voice organized by software. There are a lot of different opportunities. And on the right-hand side of the slide, you can see the warehouse. For example, if you build up a fully automated warehouse, you can build it up to 30-40 meters if you want. And you can reduce the footprint by 60%, which might be needed. You can optimize the stock movements, and yeah, you can increase a lot of efficiency. And if you take all this in consideration, we found out that you can save up to 29% of energy for a normal temperature warehouse. And if you go up, if you see a deep freeze warehouse with a deep frozen environment, you can even more energy costs save. You can have a saving of up to 40%, which is really quite a lot. In the next slide, I would like to give you just one technical example how to not even reduce, also to regenerate energy. So if you take a stacker crane normally have 3 motors, one motor for drive in X direction along the aisle, another motor to lift the load up and down, and another motor for a telescopic fork to bring the pallet into the rack. And for example, if the motor for running the stacker crane in X direction along the aisle is breaking, then the motor is generating energy. And in former times, the energy was just wasted. But in the meanwhile, you can use this energy, for example, for the other motor, for the motor who is lifting up the good on the lifting carriage. So you can reduce the energy consumption between 10 to 15%. And even you could do another step. You could, the produced energy, you could bring it back to the grid, to the network. For example, for the other stacker cranes, for the conveyor system, or even for the lightning. And if you use this opportunity, you can save up to 25% of consumption of the energy. So this is just one example to have such a modern technology, not even to reduce, also to generate energy and to bring it back to other components in the system. Yeah, coming to the topic on the next slide, coming to the topic of process improvements. Here we see 2 main factors or 2 main tools. On the left-hand side, so you see a warehouse management system, which will organize all the operative activities in the warehouse, and minimize the movements of the goods, or minimize the movements of the people who are there for picking. And you optimize the space, or the use space, the storage. So there are a lot of opportunities to optimize by a really intelligent and management system with a lot of strategy. On the right-hand side, you see the energy management system, which controls all the technical equipment like the lighting or the cooling machines or the heating machines or whatever. And if you bring the factors together, you can have a lot of activities. For example, the warehouse is designed for proper performance, like let's say 100%. But in downtown or in periods where you do not have so many performance, you could reduce the speed, you could reduce the acceleration of the equipment, and then you can also use less energy. On the other hand, you can take care that doors are closed. If the pallet is transported through the gate, then immediately after it, the door will be closed. So there is a connection between the warehouse management system and the energy management system. And if you combine this, you will have a lot of positive effects. Coming to the next slide. This is one of my favorite slides. On the left side, you will see the movements in a warehouse. It could be a fully automated warehouse, or it could be just a manual warehouse. You see the stock movements in a warehouse without any optimizations. The pallet is stored somewhere, and then there is an order for a pallet. You have to pick the pallet, and yeah, it doesn't matter. There's no strategy behind it. If you have a proper good software, which are strategy behind, you can get much more effective stock movements. So you will have less way to go. You doesn't matter if is it the people, the employee, or is it a machine? So you can reduce the numbers of kilometers, and you will have a lot of strategy. Like you have fast movers; they will be at the beginning of the warehouse. You will have maybe slow movers; they are in the back of a warehouse. So there are a lot of different opportunities to optimize to have the right strategy, and then you can reduce also the movements, which is also good for the performance, to have more performance with machines or with the employees. But on the other hand, of course, you reduce also the consumption of energy. Yeah, coming to the next and final slide. We have seen the three pillars. We have seen the three areas. Design of the building, design also the equipment, the internal equipment of a warehouse, or even also for the production. And you will have processes, and of course they will need energy, but you can optimize them. And yeah, I like the sentence, to cut energy where it is not longer needed and direct it to where it is necessary. So really to be efficient with the energy consumption. And on the right-hand side of the slide, you see some final figures as a summary of some keynotes. We learned that a stacker crane can generate energy, for example, and with that activity, you can reduce up to 20–25% of the energy consumption. With the optimization by the software, you can have another 20% of optimization and savings in the energy. To bring it together with the energy management system, then you can have additional savings. So overall, I would say in a deep frozen warehouse, you can save up to 40 or maybe even more than 40% of the energy consumptions. And there might be maybe in future another aspect. So if there will be a link between the energy consumption and maybe some taxes, you could reduce also some taxes if there might be, if you are using less energy, or even give energy back by a photovoltaic system, as we have seen in this one example, then you will pay less tax or maybe even get some money. Yeah, that was a short introduction to this topic. I think it's quite there might be a lot of things to discuss, and might be some questions. So yeah, are there any questions, Tom?
Thank you, Mark. That was fantastic, and like you say, that was